Thank you. Awesome. Recording. Man, Jessica, I don't know what I would do without you, girl.
The reminders are coming in.
I know. I get, that list, you know, co-host, are you recording? Have a good day. Good luck. Um, so we are gonna do another sorting activity for today, just to get ourselves to remember what we did yesterday. So there are a couple of you guys that were not here yesterday that are here now. So for those of you guys who weren't here yesterday, remember the YouTube video is up, so you guys can always watch that. But everything that we're doing today is going to be very similar to what we did yesterday. Actually, if you guys didn't know, today is February 2nd, which is Groundhog's Day. And if you've never seen the movie, it is absolutely phenomenal. You will absolutely love it. I mean, it is an old movie. I mean, I am old, so I love old movies.
Then why didn't we stay off?
No. Well, okay, it's not that kind of holiday. But the movie is about repeating the same day over and over and over again, which is kind of, funny that we're not repeating, but we're doing another activity that is very similar to what we did yesterday. So keep in mind everything that we were doing yesterday, because a lot of the tricks that helped you guys yesterday is going to help you guys out for today. So for this first activity, if you guys weren't here yesterday, or if you're still a little confused on what we did yesterday, do the best you guys can as we go through it. Then I'll still give you guys all the answers. You'll catch on to a lot of the things that we did yesterday. And then as we move forward with the activity, you guys are going to be like, oh, this is super easy, and be like pros at it. So then after the sorting activity, Ms. Gomez is going to take over. She's going to do a Desmos after the sorting activity, Desmos activity after that. I don't know. I wasn't sure if I said that actually correct or not.
You did.
So you guys are going to do that. You do have a homework assignment. It is 4 questions. So it's very small. It's all building off of everything that we've been doing for the whole week. Well, last week, not necessarily this. Well, kind of like everything's building off of each other. Don't forget, we do have tutorings sessions, but Ms. Gomez and I do have a meeting for for today's tutoring session, so we're not offering it today. However, tomorrow from 12:30 to 2, you guys have the opportunity to be with us and catch up on all those missing assignments. If any of you guys were having any issues, or if you guys weren't here yesterday and you want to come in and be like, hey, how do I do it? Come in tomorrow from 12:30 to 2, and you guys can get help from that. Next Thursday, you guys are going to have a practice test. This test is going to give me an idea, or give us an idea of what you guys still need help with, so that when we come back from our 4-day weekend, yes, we have a lovely 4-day weekend, we will be able to give you guys a good review on the topics that you guys are still having some issues with. Speaking of the 4-day weekend, if you know anyone from Desert Sands and they're telling you about their weekends off, it is different than ours. It is, so yeah. So for those of you guys going, wait, when we have 4-day weekend? Yes, it's the weekend of Valentine's Day. So it's next Friday, then Saturday, Sunday, and then Monday. So that's going to be our 4-day weekend. After we come back from the 4-day weekend, we have 1 day to review. We have a Wednesday, and then we have our tests on this entire unit. But you guys are already doing absolutely fantastic. I'm pretty sure if I gave you guys like half the test now, you guys would all ace it, because you guys have been doing absolutely phenomenal.
You guys are great.
Yeah, you guys are like amazing.
I saw that in your quizzes. They were amazing.
Yeah, I mean, you guys are like doing fantastic. Like, you guys are making me look bad. Like when I was your guys' age, I was doing exponential functions, and I thought it was the hardest thing ever, and you guys are making it look like cake. And I was like, what? This is supposed to be hard. You guys are supposed to struggle, and you're not struggling. You're like, man, can we just get the homework assignment and let's just be done with it? So amazing job, guys. I do want to bring your attention to the page. There is a guest with us in the Google Classroom. Do you guys see?
Yeah.
Yeah.
It's Miss Gomez. She has joined us. She's like, hey guys, how's it going?
Let me in.
So she figured out how to set it all up, which is awesome. So now she has joined me in all of my Google Slides, which is great.
What took me the longest is finding the right outfit. No.
You know, that's always hard, you know.
I don't know about you guys.
So, you guys join me in Google Classroom. We'll be in classwork. We now have everyone here, which is fantastic. So for those of you guys just joining us, you got here just in time because we're about to get started. So if you go to classwork under week 5, scroll down, and before you click on view more, or at least on my screen, I don't have to click on the view more. It's going to be right here. So under translations, linear sorting activity. Yeah, we have a full class. It's actually, you know, pretty nice. So we're going to click on class kick. Remember, you guys should be logging in, but because I don't want to log into my teacher account, I'm going to type in my name, Doc3, and I'm going to hit continue. And this should look very similar to what we've been doing in all of our morning activities. So we have translated up, translated down, which is what we covered yesterday. Notice we have hints. It says there should be 3 pieces on the upside, 3 pieces on the downside. Under directions, it says sort the pieces below as translated up or translated down by dragging them to the correct box. There might be some that are neither that will be left out of the box. So think of strategies of what I've told you guys before. What would probably be easier to deal with first and then move on to the other ones? Now, some of these, you guys might look and be like, okay, it can't be that easy. She wouldn't make it that easy. And honestly, yeah, we're not mean teachers. We want you guys to succeed. So I'm going to give you guys the length of a song to do this, which means I need to pause. And Jessica, you need to remind me to like unpause the recording.
Oh, yeah.
You are like,
yay, Jessica. And I was about to say that at least you guys get to see us after 2 days of not seeing it.
Exactly. Yeah.
For real. You know, whenever we come to this class just makes everyone feel better.
Oh, that's great.
We love hearing that though.
Yeah.
And I'm glad that you guys feel that comfortable. So amazing work, guys. All right. So because for me, doing graphs are a little bit easier, I'm going to go that route first and pull up all of my graphs up as we're going through this. Now, if the words were easier for you guys, and hold on, you guys can become experts on that in just 1 second, but I am old and graphs just make more sense for me. So I'm going to zoom in a little bit on these guys. Now, let's think about what we did yesterday. What did we see yesterday? What kind of graphs did we see? What patterns did we see? So keeping all of that in mind, let's look at these 3 graphs. Now, think process of elimination. I have 2 graphs that look similar. I have one that looks like an X. Now, knowing that, I would probably say, well, I have an up and I have a down. I would probably think these 2 are my answers and this one should probably be kicked off. Also thinking about what we did yesterday is I never had any crosses. And if we look closely, if I zoom in super carefully and I look at my equation, I have y equals x and y equals negative x. And I specifically said, don't change your shape. That line needs to stay the same way at all times. So since this person decided to not listen to me and changed it up, then we know that this is going to be a neither because they don't know how to follow directions. All right. We want to pay attention to only people who follow directions, like you guys. So looking at these two, we can then figure out, okay, I have y equals x plus 6. Do you guys think that's a translated up, or do you think that's a translated down? Let me know.
Translate it up.
Translated up. Can anyone let me know why it would be translated up?
So it's a positive.
Yeah, we see that plus 6 right there at the end. Think about that. Remember that at the end, right? That plus 6 at the end is letting me know that I'm moving up 6 units up.
Good
So
job.
because of that, we are moving up, which means if I have an equation like this and it says y equals 2x minus 4, then what would that be?
Translated down.
Translated
job.
down. Since we have a negative 4, that's telling me I'm going to move down 4 units.
Mhm.
So far, so good. Awesome. All right. So I'm going to zoom out a tiny bit again. And I'm going to move all of these pieces up just because I don't want to have to switch up and down. And there. And now I can zoom in. All right. So remember, I always tell you guys, read all of them, all of your directions first, or all of your pieces. And then you can do, again, process of elimination. Looking at all of these pieces, 2 of them, you're probably like, wait a second. It actually says up and down in it. It can't be that easy, right? Like she must be like tricking me where like down is up and up is down. It's like, but is that the case? No, we're not that mean. And honestly, like we've been talking about this for a while now. So shifting the graph up along the y-axis, obviously I'm talking about down, right? So because I'm trying to trick you guys. Is that true? Yeah?
No.
No, I'm not that mean. Again, so we're going to be shifting up. So whenever I'm shifting up, I'm obviously translating up. I'm moving this apparent graph all the way up. All right, which means that this would be shifting down. I'm taking that red line and I'm going to shift it down. And I'm shifting it down the y-axis. We're not moving it left and right. We're just going up and down. So now we have 3 options left. Again, we need to be talking about translating up and down. So we need pairs. So think about it. This is adding a constant to the original equation. This says flipping the graph across the y-axis. This is subtracting a constant from an original equation. I have adding, subtracting, and flipping. Which one of those words did I not cover yesterday?
Flipping.
Flipping. We never talked about flipping. We only talked about movement, shifting up and down, left and right. So flipping is probably going to be one of those neithers. We're not going to be dealing with that because we didn't talk about that before. So I'm left with adding and subtracting. Adding, which would adding be under? Would that be under up or
Up.
down?
Up.
It would be under up. Why? Because I see this plus 6. So that plus 6 is going to tell me that I'm going to be adding a constant to whatever my parent graph is, which obviously means, again, process of elimination. Subtracting a constant from the original equation means that I'm going to be going down. See, I have the 2x as my parent, and I'm subtracting 4 in order to bring it down. All right. So, once you guys are done with that, give me 1 second. Let me see. We're gonna go over to our class. Oh my God, Ms. Gomez, you see this beautiful number right here? You see how awesome they are? So I absolutely love the fact that you guys have been getting into that habit of I'm done with class cake. Go into Google Classroom, mark it as done. The fact that you guys are going through that step, you're making sure that you never go, oh my goodness, I forgot to mark that as done and I didn't get those points. Oh, look, now it's 13. Oh, I love these numbers. So fantastic, guys. You guys are doing absolutely amazing. Again, once you're done with class kick, please make sure to mark it as done. For those of you guys who are having internet issues and you guys need to take a screenshot, by all means, please take a screenshot. For those of you guys who missed yesterday, make sure you are asking questions today as Ms. Gomez is going through the activity because it's almost identical to what we did yesterday. So everything that we did today will help you guys out with the activity for yesterday. All
Yeah,
right?
and keep these words in mind, translated up, what we were doing, shifting up and adding, translating down, those shifting down and subtracting. Keep those things in mind because you're going to see them today as well.
So before I give up power, ooh, look, 6 people have already done the
Already?
homework. So absolutely fantastic, guys. So your activity or your assignment for today, I'm just going to put in some random letters because I'm not actually going to submit it. But we have an equation that kind of looks like what we're going to be covering today. But again, process of elimination, guys. Have we dealt with a graph that looks like this? Are we dealing with a line when we have an exponent? All right. Also, think, I have a whole number. Is that decreasing or is that increasing? When I have that too, am my numbers getting bigger or are they getting smaller? So all those things are going to help you guys out to at least do a process of elimination with some of these. You guys are going to tell me what the domain is, and then you guys are going to tell me what the y-intercept is. Once you have all of those, just hit the submit button and boom, you guys are done with your assignment for today. But that's for your homework. I am now going to give up control.
To
And Ms.
me.
Gomez is going to take over.
All right, boys and girls, I am going to be sharing my screen so we know what we are moving on to next. But I already see in our Desmos activity that some of you are way ahead of us. Okay, you want to make sure you're in Google Classroom on that classwork section. Go right below to where it says week 5. And right above the activity you just worked on right now, that translations, linear or sorting activity, you see your Desmos activity, which is called dots transforming exponential functions. Click on that and click on the link. Okay, type in your name. And I want you guys to go ahead and click, here we go, and click go. I have it paused for now because I'm giving students some time to join, but the majority of you are already here. Hiron, I see you. Thank you. Alexis, Jonathan, Jessica, Cassie, you're already here. Anthony, Jonathan, Alondra, Suleima. Man, so many of you are really fast here. Yaeli, Melanie, Manuel, America, Fer, me, Alfonso, Daisy, Adrian, Lisandro, Alexis. Again, if you are choosing between watching us on Zoom and joining your Desmos activity, let me move that over here. Okay, because of your connection issues, then let us know so we know, and that's the reason why we don't see your name here. Okay, Isaac, I think that was from the translation ones, but give me a thumbs up, Isaac, if you're okay and you can see the correct activity. Go to Google Classroom, right above translations. Okay. Okay, so we're gonna go ahead and start. Okay. Thank you, Isaac. We're gonna go ahead and get started. I'm gonna go ahead and unpause this, and I'm going to restrict you to the first slide.
Remember, Isaac, if it doesn't load and you've refreshed it a couple of times, always just take screenshots of what we're doing, and it might just be an internet issue. So it's either Zoom or doing Desmos, and you can always just write your little notes about what we're doing. Okay.
And we'll let you take screenshots of the pieces we want you to make sure you have. Okay, so I'm going to go ahead and explain what we're doing in this first slide. This is exponential versus linear predictions. You're going to predict how a vertical shift, remember that word shift, we were talking about it earlier, just a translation up, moving it up, or moving it down, translating down. Predict how that kind of shift is going to happen on an exponential function. Do you think that's going to be the same or different than the linear function in terms of what it does to both the graph and the equation? So today we want you to see what kind of translations are happening to our exponential graphs and how they affect your equation. Yesterday, you guys got to see how a translation on a line affects it when we go up and when we go down. So what do you guys think? Is that going to be the same or is that going to be different from what we saw yesterday? Let's take a look at a couple of your responses. And think of the activity you just did. Okay, that was kind of to refresh your memory about yesterday, the translating up, what it looked like. We were adding at the end of the equation. The translating down, we were subtracting at the end of the equation. Or when we looked at a graph, we were moving it up along the y-axis, or we moved it down along the y-axis. Do you think that will be the same, or do you think that will be different? Okay, we see some of you saying, I think they're going to be the same. It's a prediction, boys and girls. We don't know if we're right or wrong. We're not asking for you to be right. We're just trying to see what you think. Going to be different, okay? Yeah, maybe.
Wait,
Ooh.
what was the assignment name? Dogs transform, which one?
Yes, Hiron, it's Doc's transformation of exponential functions. See that name right up here?
Yeah.
Should be the same.
Okay, thank you.
You're welcome. Okay, I saw a really good response. It says, my prediction is that it will be different due to the fact that a linear function is constantly going in a pattern, in an adding pattern, while as, I'm reading these as you guys are typing them. Okay, so we have pretty half here, pretty 50-50. Some saying it's different, some saying it's the same. Well, that's what we are going to be looking at today. Remember, we've been comparing linear versus exponential in this unit, and we want you to see what happens when we're translating our exponential graphs and equations. Okay, I am going to open up slide 2 and slide 3. These two slides are going to look very similar to yesterday. Slide 2 is open. Slide 3 is open. And let me move this one along. Okay, so we're starting off with the graph here. You have 3 graphs, 3 different colors, the red one, the green one, and the purple one, just like you did yesterday, but notice the shape is different. What kind of shape does this graph have, boys and girls? You can either let me know in the chat or you can unmute yourself. What do we notice about this shape? On slide 2. Okay, I'm getting a direct message. Yes, good. Anybody else? Ooh, good, yeah. Okay, I have someone using the word exponential. It is exponential, good. What about the shape tells us it's exponential? What do we call this shape? Yeah, good. Yes, a curve, perfect. Yes, we see a curve. Now take a look at this curve here. Is this increasing or decreasing? Start from the left, follow it along with your finger.
Increasing.
Yes, good job. Increasing. Okay, so let's take a look at our directions here. It says transformation of an exponential function. Below is an original exponential, y equals 2 to the power of x. We have that there to show you how you can type it in the next slides. but it's just y with the equal sign. We need that y with the equal sign, the 2, the little caret above the 6, and then you type in an x. The equations had 2 different transformations done to it. Hold up a piece of paper over your device and trace the red function. So if you have a piece of paper available right next to you and a pencil, go ahead and take that piece of paper and hold it up to your screen or monitor and trace the red curve just like you did with yesterday's graph, but that was a line. If you do not have a piece of paper, we have a different option for you. You can use your hands. Okay, see when I stick out my thumb with the index finger here, I get curves. Looks very similar to your graph on there. But I realized this yesterday, our video shifts the image. So I'm holding up my right hand, but I'll show you this one with the left. So you want to hold up your right hand, hold that up to the screen, match it to the graph. Now what you want to do is check the movement. Move that hand or the line that you traced, move it up or down, move it left or right to see how you can get the green graph. And then what you want to do is follow the same steps, but see how you can get the purple graph. And some of you might catch on to this really quickly like yesterday. Okay, when you're done exploring how we can get those graphs, slide 3 is open where you can describe what you're seeing. What is the transformation that is happening? What happened to the red function to get the green function in the previous slide? Think of the movement that you did. How did we go from the red one, this one, from the red one to get to the green? The next slide over here says, what happened to the red function to get to the purple function? Hold up your hand and follow the graph from the red to the purple. What kind of movement did you see? And try to use your transformation vocabulary. Remember, we just talked about those in your sorting activity. Try to use that. For those of you that are not on slide 3 because you haven't caught on yet, I'm gonna go back to slide 2 and give you some pointers. Okay, let's look at this red graph here. We want to look at our y-intercept. Okay, that's where our graph is crossing the y-axis there. We get 0, 1. If you click on the green graph on its y-intercept, you can also see where it's located. Take a look at that 1 and that 3. Think about what kind of movement is going up to get us to the green graph. You can also repeat the steps with your y-intercept here. This purple one has a y-intercept at -1. Think of what kind of movement we had to do to get there. Okay, I'm going to take a look at some of your responses. You guys are doing amazing. Yep, perfect.
Some are already bragging to me like, oh, I already got this.
That is awesome. Okay, I'm going to move you guys along because you got this one really fast. It says the red function had to go up by 2. So I am seeing a lot of vocabulary that's saying shifting or moving. And you guys are telling me by how many units, by how much. Yeah, so the red function had to go up by 2. It shifted up. Good job. And on the other side, you guys, oh, I forgot the up here. On the other side, you guys are saying moving. You guys are saying it's shifting. And I see the word down, 2 units. Okay, so is this similar to what we saw yesterday with our linear equations in the beginning? Give me a Y for yes, give me an N for no on the chat if you're starting to see if this is similar, yes or no, or you can unmute yourself. Similar, yes, or not similar to what we saw yesterday? I got one direct yes, similar. Okay, let's take a look. So keep that in mind. I'm going to move you guys along to slide 4 and 5. Thank you, Cassie. I'm going to move you guys along to slide 4 and 5, where we get to see how these shifts, how these movements up and down could be affecting the equation. So keep in mind what we did to the equations yesterday. We said we're adding and we said we're subtracting. Could that be the same thing here? Try it out. Predict what your equation will look like for the green function, the green graph, and predict what it's going to do to our equation for the purple line. So let me read these to you. It says, how does the transformation affect the equation? We noticed that the red graph was translated up 2 units, and you guys did an awesome job there. To create the green graph, how do you think this affects the equation y equals 2 to the power of x? So go ahead and type in here, what could our equation be looking like? Also, go ahead and type down here what the equation could be looking like for the purple graph. And just like yesterday, you guys can move along to slide 5 and type in your equations on these rows to see if you get a match. So whatever equation you're predicting here, I don't know, let's say 2 to the power of x. And I'll give you guys some examples of what I saw right now, but let's say, I don't know, we're saying maybe I'll add Jessica, slide 4. Okay, can you guys give me a thumbs up if you're able to see slide 4? I do have students, 7 students on, well, more now. I have students on slide 4 and slide 5. Yeah, okay. Jessica, go ahead and try refreshing.
I was about to say that. Yeah. Guys, that's always the answer. Refresh. That or shut down and then open it up again.
Mm-hmm. So go ahead and refresh or close it and reopen it. It should save your progress. Let me know if you're having issues after you're doing that, okay? But again, you can follow along with us. There's going to be the video. You can also complete it afterwards. Okay, let me take a look at what you guys are saying for your equations and how you're doing with matching those on slide 5. Oof, good. You guys have caught on. Okay. Let's say this is my example. Maybe there should be a negative in front. I can go to slide 5 and I can go to that second row and type in my prediction. I said maybe I can take a negative and put it in front of the x to the power of x. And what does that do? Okay, give me a thumbs up if this is a match. Did this equation that I typed in give us a match to the green or the purple? Give me a clap if it did not. Good. So one thing you want to notice is when we change anything in the front here, okay, it's not going to match to any of these. So perhaps nothing in the front. Perhaps we can try what we did yesterday, making a change in the back. Okay, perfect. Okay, yes, thank you for letting me know. If you are having Wi-Fi issues, don't worry, we are recording this. Yes, she did press record after that music. So we are recording this. You can follow along with us in the recording.
Man, no faith. No one has faith in me.
You can follow along with us in the recording afterwards. But if I'm losing you in any of these, still send me those direct messages. I can explain it a couple more times, but thank you for letting us know. That way I know why you stopped following along after a couple slides. Okay, let's take a look at the equations you guys were working. And I'm behind. You guys are all having matches already. Good job, you guys. Okay, since you guys did really well, is there anybody brave enough to tell us what should I try doing to this equation to get the green graph? Anybody? You can type it in the chat or unmute yourself.
2.
Yeah, let's try that. That's okay. Okay, remember we were at 0, 1 here. And as I'm trying to get to that green graph, I notice I'm going up by 2. How do we make something go up by 2 in math? Well, we can always try addition. That always makes us go up. And we want to go up by 2, so we add 2. We get a match. So far, we're noticing a similar trend to yesterday. We're taking a number in the back and we're adding to this equation there. So plus 2, I saw a lot of those equations there. Okay, let's take a look at the red graph. Going to the purple graph. Okay, we start at 0, 1. We're moving down by how many units? And when we move down, what does that mean we should do? I'm going to try something though, in case some of you, that's okay, thank you. I'm going to try, again, the minus 2x, since I'm going down. That's not working there, so I won't try that. Let's delete that and try that. Okay, I know I went down, so I added a minus, but that's not working out. So not in the front, not changing anything in the front. So
Wouldn't it be y equals 2 to the power of x minus 2?
you got it, Alondra, good job. Yes, perfect. Keep in mind the movement we're doing. We're going 1, down 2. What do we use in math to show we're going down? We're decreasing, we're going down by 2, so minus 2. And we get another match. Okay, so far, for those of you that predicted that we're doing the same, it's having the same effect, you guys are we're on the right track there. Okay, I'm going to move you guys along to a new type of graph, slide 6 and slide 7. But remember, boys and girls, we only change the back here and following the shifts of up, following the shifts of down. Okay, slide 6. We're repeating the same steps, but now we have a different type of equation and we see it's a different type of graph, but still maintaining the curve. Okay, that's fine. Okay, below is an original function y equals 1/2 to the power of x. In red, the function had 2 different transformations done to it. So here's our original graph, the red one. Something happened to it that gave us the green graph and the purple graph. So you want to do the same here. You want to hold a piece of paper, trace the red graph, and then make some movement to get to the green graph. Go back to the red graph, make some movement to get to your purple graph. If you don't have a piece of paper, remember you can use your hands. In this case, you'll want to use your left hand, okay, which would give us that downward shape. I got it right this time, Dr. Brown. So this is what it should look like on your screen. Notice we're going down, okay? Use your left hand to move it along either upwards direction, downwards direction, right or left to get your new graphs. But before, I know some of you guys are already trying that, and some of you guys are already on slide 6. Ooh, and so many of you are already ahead and giving me the equation. Okay, let me move it along. So keep in mind, look at your y-intercept. Here we are at 0, 1. To get to that green one, we can look at our y-intercept too and take a look at what could be happening here to move those along. Same thing, look at your y-intercept here. We were at 0, 1, and now we're at -3. What could have happened to move us there? But a little bit of review, because I want to make sure you guys are remembering this. Is this an increasing or decreasing graph? Start from the left, follow it along. Increasing?
Decreasing.
Yes, good job. Decreasing. Okay, it's still exponential because we have a curve. Notice these are all the same curve. They just moved in a direction. And describe what kind of transformation is going on here on slide 6, which I know a lot of you are already on? What happened to the red function to get the green function on the previous slide? Describe it using transformation vocabulary. On the other side, describe what happened to the red function to give us the purple function, and describe it using transformation vocabulary. Okay, I'm going to take a look at some of your responses. You guys are amazing, amazing, amazing. I don't see any wrong answer here. Okay.
You guys are going really fast.
Yeah, they're like zoom, 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 zoom. Okay, I will move it along because all of you are here and ready to go. Okay, we are moving. I see shifting. I see translating. All of these words mean the same thing, shifting, moving or translating. But what I do want to see is this word up, which everybody is giving me. And you guys are also giving me how many units we're going up. Okay. On the other side, I see that you guys are describing these translations as moving or shifting or translating. And I see that word down, and you tell me how many units. Okay, so if we're moving up or moving down, how is that going to affect our equation? I am going to let you guys move on to the next 2 slides where you type in your equation and you check your prediction for your equation. And keep all these things in mind for your homework, just like Dr. Brown told us. Okay, the shape, increasing, decreasing, where we got those. And how do we change the equation? Okay, here we go. How does the transformation affect the equation? We notice the red graph was translated up 4 units. So those of you that were giving me 4 units, which was all of you, you were correct. We did go up 4 units. How do you think that's going to change our equation? What part of our equation changes? Maybe the fraction, maybe the sign, or maybe the end? Is it the same as what we saw on slide 2, 3, and 4? We noticed the red graph translated down 4 units to create the purple graph. How do you think this will affect our equation? If any of you are having a hard time typing in the fraction, let us know. Or better yet, let's do this. Give me a thumbs up if you're okay with typing the fraction. Give me a clap if you want a refresher of how do we type in this fraction. Thumbs up. Okay. So remember, our original equation was y equals, this time I'll start with the parentheses since I see that there. 1/2 if you're using a keyboard, but if you're not using a keyboard, go over to this keyboard option and you can see your fraction option there. 1, bring it down, 2, close your parentheses, and then remember this option here lets us get the x as the exponent. Is this half supposed to change? Is the back supposed to change, or is the front supposed to change? I am going to take a look at your guys' equations.
Yeah, I was looking at theirs, and then all of a sudden I look and I saw someone wrote y equals 1, and I'm like, who is that? And then I'm like, oh no, wait, that's you still typing in all
Ms. Gomez is the only one behind everybody.
Exactly.
But that is amazing that you guys are already there, and I see correct ones. Good. Okay, make sure you don't forget the y equals part. If we don't have that, we can't call it an equation, then it's just an expression. Okay, when you have an idea or your prediction for your equation, go ahead and test it out on the next slide. use the rows to type in your equations. Don't forget, you do need the y equals and whatever equation you had. See if you get a match. And in a couple seconds, I'm going to ask you guys to share, if you'd like, what you got for your equation here and if that was a match.
She like just opened it up and you guys are like already on there and you already wrote everything in. You guys are too fast.
Yeah, you guys are amazing. And they're also playing around with the different color lines. You're like, I don't want to use green. I want to try a different color line. Okay. Let's try these out. Okay, so y equals. Well, if I decide to change that number in the front, remember our pattern, which we call our constant multiplier. Oops. And I try something like that, I get a completely different line. Not even the same shape. It's, well, yes, it's a curve, but this one is increasing and this one is decreasing. So always remember that a fraction gives us that decreasing line. So changing that number in the front does not give us the correct line. So it might be a good idea to keep the half. Our constant multiplier needs to be the same for now, is what we're thinking. Don't forget to put the power of x there. And anybody that's brave enough to share what we can do to this equation to get the green line. Keep in mind we were at 0, 1, and we're now at 0, 5. Fed, are you using iPad or a computer? iPad.
Yeah, it might be that if you don't see certain options and you're on an iPad, it's because of how old it is.
Yeah.
It might be just that. But if you just open up your normal keyboard, like the one on your computer or on your iPad, you should just be able to do the slash and it'll automatically make the fraction. Or
Yeah.
if you click on the button that looks like a keyboard, you'd be able to do it from those options too. But if not, don't worry. We already know, like you just talking to us lets us know that you might have issues with the fraction. So as long as you understand what we're doing, that's all that we're asking for. So do the best you can with what you got, basically.
So we can't get on the keyboard. Okay. Yeah, it might be your device.
Yeah.
Mm-hmm.
I know a lot of iPads, they have that issue. Granted, I think Egypt half the time is on his phone.
Oh, I see.
So
Yeah.
it would be very difficult on the phone.
Yeah, it even says that there might be some issues with the phones.
Yeah, but guys, as long as you let us know that you're having issues, this is the only part that you should have issues with is making the fractions.
Mhm.
And all of our assignments and our tests and quizzes and all that stuff is not going to be on Desmos. This is just one way of us showing you guys everything. So if you guys are having issues, as long as you like can write out the idea behind it, so you can even make it so that it's wrong by just putting like 1 and then space and then 2,
Yeah.
just to give us the idea that you understand what we're doing.
Just like that, 1 space 2 to the power of x. What we're really looking for, boys and girls, is, why do I always capitalize that? There we go. Is what you do after that. And while we were on that conversation there, I got a lot of direct messages and some students trying to tell me what we can do to the equation. Let me go back here. Okay, I got somebody saying, is it +8? Let's take a look. Unfortunately, I don't see a new graph here, so I can zoom out. Take a look there. It went over to 0, 9. So let's go back here. Look at that 1. Moving up to the 5. Think of how do we get from 1 to 4? And the rest of you.
You gave the answer.
Yeah. Oh,
At least it's not just me doing it.
did it too. I meant to say, how do we go from 1 to 5? But it's because I'm staring at your guys' answers on chat. It's +4. So we want to see this part. If you're struggling with getting the fraction, that's totally fine. This part tells us what we need to do to change the equation to get a translation. And you guys, I see it on your graphs. You all have matches, which is good, but you're probably going to have a hard time with those functions there. Okay, so let's see if I don't mess this one up. We're going from 0 to 1 here on your curve for the y-intercept down to a 0, -3. So what will we have to do to our original equation here? Yeah, I already got some answers before I even get there. And okay, another one's coming in. Power of x. What we'll have to do, yes, good job, America. Jessica, good. Sulema, perfect. What we will have to do here is bring it down. Bring it down. Think, what brings this down in math? Subtraction. How much do we have to go down? 4. So we bring it down by 4. So every single time we have these equations, we're changing our constant. We're changing the back number here. If we wanted to go up, we add. We wanted to go up by 4, we add 4. If we wanted to go down, we subtract. And we subtract by 4 to make the graph go down by 4. Very important though, this is not changing. Okay, our multiplier, our constant multiplier is not changing, it's staying the same. Okay, you guys are ready to move along. I'm going there. Okay, the next 2 slides are just making conclusions now. Making some summaries. And then you'll have some independent practice. We are gonna go ahead and skip slide 10 because you guys are very familiar with drawing your graphs. You know the difference between growth and decay or increasing and decreasing, but what we wanna get to is your summary, okay? Were you able to identify what a vertical shift does or how it affects an equation of the graph of an exponential function? So we're talking about the equations we were just writing. Okay, when you had a shift up or down, how did that affect our equation? So give us a couple of words here to describe that. And then down here in the bottom, it says, describe what the effect K has on the graph of the function y equals a times b to the power of x plus k. Don't forget, we are skipping slide 10, so I'm gonna go ahead and move you guys.
Yeah, some of them were like lagging. I'm like, no, why are you there? Move.
Yeah. Don't worry about that one. I am going to move you all along to slide 11. So everybody should be on slide 11 so you're not confused. We are not working on slide 10. That's just drawing stuff we've already drawn in the past. Okay, but I do want to see your responses here. And the rest of these slides are just going to be practice, writing equations that match the shifts. So keep in mind that movement we were making with our paper or our hands. Okay, those are our translations up and down or vertical shifts. How did that affect our equation? Up, down. What were we putting in those equations at the end? And this looks a little new, but we've seen it and some of you guys were confused. This is what we were trying to get you guys at before. Okay, describe what the effect K, this K here, oh, I can't highlight it. What does that K have on your function, on your graph, or on your equation? All right, let's take a look. Okay. Ooh.
I love how exact some of them are getting.
Yeah. I have a good question though. Is it the y-intercept? Well, let's take a look, Jessica. Oh, I restricted myself. Maybe.
It isn't like the other one though. It is like the y-intercept because the other one has the slope exponent.
Mm-hmm.
So it is like the y-intercept.
Okay, give me 1 second. I'm gonna do this and show you with slide 2. I've opened up slide 12, sorry. Think about this one, 0, 1. It is like thinking about the y-intercept, but in these y-intercepts, we're always at 0, 1. Remember that? That's because our equation has that invisible 1 in the front. Remember your equation? Let me type it up here, but that is a very awesome question. So A times, let me put my times B to the power of X. This Y here, Jessica, was your y-intercept, right? And this was your multiplier, your pattern. So technically, we have that invisible 1 in the front. Okay, so this one matches that y-intercept. So we still have a y-intercept in this 0 here, but we're just shifting it down. And that shift comes from moving the y-intercept, but it comes from changing the equation. So I see what you were trying to ask. It's the y-intercept. It's shifting the y-intercept, and the equation does that.
Yeah, so the adding and subtracting on the back is moving just your y-intercept. So yeah, you're on the right path.
Yeah. I just wanted to clarify that it's moving it. But yes, moving the y-intercept. Okay. Those of you, I am going to open up the rest of the slides. Stop pacing. Okay, they should be opened. What you want to do is start your practicing time, but the rest of these here is just practice on your own. But I do want to clarify some of these things that you guys were talking about on slide 11, and you guys were all on the right track, okay? How does a vertical shift, a translation up or down, affect the equation? Okay, I saw it affects the equation by adding or subtracting at the end of the original equation. So good. Yes, perfect. The vertical shift goes up if we are adding a positive, and it is going down if we are subtracting a negative, so subtracting a number. It affects it by shifting it up or down. Ooh, a constant is added to it. Good job with the vocabulary there. Good job. Or we subtract a constant. Very simple. This one is perfect. It tells us what we want you to understand, adding or subtracting, by adding or subtracting it. Good. Okay, the last part here, which is what we want to get to, which a lot of you guys gave me correctly here. And I got an awesome question. Wouldn't it shift? Okay, describe the effect the K has on the graph of the function. Yes, it.
I love that they're putting their questions in there.
Yeah.
It's kind of like chat.
Is it like shifting? Yeah, perfect. It is a shift. It shifts. Describe what the effect the K has on the graph on the function y equals a times b to the power of x plus x. It will shift the function up if we have addition, and it will shift the function down if we have subtraction. So, and changes to good, yeah. Keep in mind the shape. This is an exit ticket today. Yes, there will be one, and we're gonna get to that right now. Let me just say this here. The shape stayed the same, okay? We still had the same curve. So the shape stayed the same. But what did shift is the graph up or down. Okay, You guys have already left, the majority of you have already left slide 11 though. You and your summaries were correct there. What you want to do is work through slide 12, 13, 14, and 15. What you are doing is looking at the original equation and write the new equation that gets us the translation, the shifting up. In this case, you want to write the equation that gets us this original equation, this original function, to this shifting down graph. But you guys are practically finished. I'll let Doc Brown talk to you guys about the exit ticket.
Yeah, so you guys have your exit ticket already, or at least if you don't see it, you guys can refresh. And actually, let me double check and make, no, really, come on. Why don't you ever like actually
I'll
schedule
stop
it?
sharing. If
Oh,
you
no, no, not you. Like I schedule it for it to come out at 11:20 and it's 11:23 and it's still not like,
Oh,
that's why, yeah, whatever. All right. So your exit ticket is already up, guys. So is your PBIS lesson for tomorrow. So if you guys want to get ahead of the game and do that, you guys can. Don't forget to do the PBIS lesson to get your participation points for tomorrow, since there's no like Zoom class. Please do your exit ticket. And once you're done with this assignment, go into Google Classroom and mark it as done. Make sure that you guys are completing all of the slides. Some of you guys did message either Ms. Gomez or I that you're having issues because of one thing or another. I am paying attention to that. Others, some of you guys, I saw how tricky you guys are getting. Some of you guys are getting a little smart to get, some of those extra points. I do know when you guys are trying to trick me. So just letting you know, you can't like mess with me like that. Like, no. So make sure you guys submit all of that. If you didn't finish the extra practice questions as I'm talking, because I talk a lot, so that you guys can be doing all of this stuff. Make sure that you guys continue doing it after class, and once you guys are done, just submit it. But other than that, guys, you guys have done absolutely fantastic, absolutely amazing. Again, turn in your exit ticket. Do your PBIS lesson, do it today so you guys get it out of the way and you don't have to do it tomorrow. I am submitting grades today. Grades are due today. So the sooner you guys turn in any missing assignments, also look in Aries and make sure that that all the scores you guys have in Google Classroom are actually in Aries. I do make mistakes and I'm using a computer and computers aren't, 100% reliable, but you guys are free to go. Have a very good day today and tomorrow. We will see you guys on Thursday.
Have a fantastic rest of your Tuesday and Wednesday, and I'll see you guys on Thursday.
Bye. Yeah, I know. It felt really fast, huh?
That was fast.
This is how
Bye,
awesome.
dog. Bye, Ms. Gomez.
Bye.
Bye.
Bye, Doc. Bye, Miss Gomez.
Bye.
Bye.
Good job today.
Thank you.
Bye, Isaac.
Bye.